Welcome to Uma's classroom for math and science videos. This video is on the topic law of multiple proportions. That is a part of law of chemical combination from high school chemistry and AP chemistry curriculum. Hope you are enjoying my videos. So please keep on watching and don't forget to share, subscribe, like and comment. You can send me the request to make a video of your favorite topic. I'm eagerly waiting to hear from you. There are certain rules followed by all atoms while combining to form a compound. Those rules are collectively known as laws of chemical combinations. They are namely as the first one is law of conservation of mass, law of constant composition or definite proportion. This is the second one, and we already have discussed these two topics in two different videos. This is the third one, law of multiple proportion. Today's video is on this topic, and there is another one, that is the last one, law of reciprocal proportion. We will have another video to discuss this topic. The law of multiple proportion was proposed by John Dalton, and the law states that when two elements combine with each other to form more than one compound, the mass of one element that combine with a fixed mass of the other forms a simple whole number ratio. That means if two elements, suppose A and B, they are combining to form more than one compound. Let's take the first one as AB and the second one as AB2. Now the masses of B that can combine with a given mass of A. Here we can see the mass of B combining with the mass of A for this compound is 1, while the mass of B combining with the same amount of A for this compound is going to be 2. Now, these two quantities, they are in the ratio of small whole numbers. Here, the ratio of the masses of B that combines with the fixed mass of A in these two different compounds, that is 1:2, and which is nothing but a simple whole number ratio. Let's look at few examples. Suppose our elements are carbon and oxygen. So, for compound 1, they are forming carbon dioxide and compound 2 formed by carbon and oxygen is carbon monoxide. Now here the mass of carbon is 12, whereas the mass of oxygen is 16 times 2. that is going to be 32. At the same time, here the mass of carbon is 12, whereas the mass of oxygen is 16. Now, let's look at these two examples. Here the mass of carbon is fixed in both the cases. So, according to the law of multiple proportions, we have to check the masses of oxygen atoms in these two different compounds. So, masses of oxygen is 32 and 16 respectively. Let's check the ratio of masses of oxygen in these two compounds. The ratio is 32 is to 16, which is reduced as 2 is to 1. So this is of course a small whole number ratio. That means these two examples follow the law of multiple proportions correctly. Let's check with another example. Now we are choosing hydrogen and oxygen as our elements. So, in the first compound, hydrogen and oxygen, they are forming water, whereas in the second compound, hydrogen and oxygen, they are forming hydrogen peroxide. Let's check for this one. Mass of hydrogen is 2. Mass of hydrogen is also 2 in this second compound. So, here the mass of hydrogen is already fixed in both the cases. We can directly check the ratios of masses of oxygen in these two compounds to check the validity of law of multiple proportions. So here mass of oxygen that combines with a certain mass of hydrogen, that is 2, is going to be 16, and in this compound the mass of oxygen that is again combined with the fixed mass of hydrogen, that is 2, is going to be 32. So here mass of oxygen is 16, here mass of oxygen is 32. Now let's check the ratio of these two numbers. 16 is to 32. If we reduce, it is coming as 1 is to 2. And again we are getting a small whole number ratio. That means these two compounds are also in agreement with law of multiple proportions. Here I have a chart showing different compounds of nitrogen and oxygen: nitrous oxide, nitric oxide, nitrogen trioxide, nitrogen dioxide, nitrogen pentoxide. And as I already mentioned, here combining elements are nitrogen and oxygen in all the cases. So let's check the ratio of masses for all the compounds. If we look at the first example, we can see 2 atoms of nitrogen is present over here. So here the mass of nitrogen is 28, whereas the mass of oxygen is 16 only. At the same time, for compound 2, the mass of nitrogen is 14, whereas the mass of oxygen is 16. For the third one, mass of nitrogen is 28, whereas the mass of oxygen is 48. For the fourth one, the mass of nitrogen is 14 and the mass of oxygen is 32. And for the last one, mass of nitrogen is 28, whereas the mass of oxygen is 80. Now, if we look at this column, we can clearly see the mass of nitrogen is not fixed yet. To check the validity of law of multiple proportions, we have to make the mass of nitrogen to a fixed number. Let's consider this number as 14. So, if 28 becomes 14, at the same time 16 would become 8. For the second compound, it is already 14, so there is no change in this oxygen quantity. For the third one, it was 28, now it is 14, so definitely the mass of oxygen is also going to be divided by 2, and now the new quantity is 24. For the fourth one, the mass of nitrogen is already 14, so there is no change in the mass of oxygen. For the fifth one and the final one, the mass of nitrogen is again 28, so the mass of oxygen is also going to be divided by 2 and the new quantity is 40. Now, if we look at this column, we have already fixed the mass of nitrogen, and that is 14. And this column is indicating the different masses of oxygen that is combining with a fixed mass of nitrogen. Now, let's check the ratio of these numbers. It is 8 is to 16 is to 24 is to 32 is to 40. We can see there is a chance of reduction and all the numbers are divisible by 8. So we can divide all of them with 8 and we are going to get 1 is to 2 is to 3 is to 4 is to 5. This ratio is long as we picked up 5 compounds, but it is no doubt a simple and small whole number ratio. So we can conclude all these compounds are following the law of multiple proportions strictly. Here I have one numerical problem, and the problem states that two different compounds are formed by the elements carbon and oxygen. So here my elements are carbon and oxygen. The first compound contains 42.9% by mass carbon. First compound contains 42.9% of carbon and 57.1% by mass oxygen. Oxygen is 57.1%. And for the second compound, the elements are same, contains 27.3% by mass carbon. So this is 27.3%, whereas 72.7% by mass oxygen. 72.7%. Show that the data are consistent with the law of multiple proportions. So here we can clearly see the mass of carbon or the mass of oxygen is not fixed. So we have to fix the mass of any one of them. Let's go with carbon and let's find out with 1% of carbon how much of oxygen can be combined for both the cases. So here 42.9% carbon is combining with 57.1% of oxygen. Therefore, 1% of carbon will combine with 57.1 divided by 42.9% of oxygen. And if we calculate this is approximately going to be 1.33. Similarly, we have to find out 1% of carbon will combine with how much of oxygen. So 1% of carbon will combine with, let's divide 72.7 divided by 27.3% of oxygen. And if we calculate this is coming approximately 2.66. Now, this quantity and this quantity, they are the amount of oxygen for both these compounds, which is combining with a fixed mass of carbon. Here it is taken as 1%. So let's make the ratio of these two quantities, that is the masses of oxygen, and it is going to be 1.33 is to 2.66, and there is a chance of reduction. After reduction, the ratio is going to be 1:2, and no doubt this ratio is a small whole number ratio, so of course the data are consistent with the law of multiple proportions. We have another numerical problem over here which states that in the carbon compounds ethane, this is the formula of ethane, and ethylene, this is the formula of ethylene. Both these compounds are organic compound. These two compounds are organic compounds. What is the lowest whole number ratio of hydrogen atoms that react with the same number of carbon atom? So here directly it is not asked whether the compounds are following the law of multiple proportions or not, but based on the theory or the statement of law of multiple proportions, we have to solve this problem. So the first compound is ethane, C2H6, and the second compound is ethylene, C2H4. In both the cases, we can see the number of carbon atoms are same. So definitely the mass of carbon atom in both the cases I mean in both the compounds would also be same. So here the mass of carbon is 12 times 2 equals 24, and the mass of hydrogen is 1 times 6 equals 6. Let's check for this compound, ethylene. Here the mass of carbon is again 12 times 2, that is 24, and the mass of hydrogen is 1 times 4, which equals to 4. Let's look at the masses of carbon atoms in both the cases. Here it is 24, here it is also 24. That means everywhere hydrogen is combining with a fixed mass of carbon, and that fixed mass is 24. Now let's check the ratio of the masses of hydrogen which is combining with this fixed mass of carbon. From these two compounds we are getting the masses of hydrogen equals 6:4. We can clearly see there is a possibility of reduction. So by reducing this ratio, it is coming 3:2. Let's look at the question. The question is asking what is the lowest whole number ratio of hydrogen atoms that react with the same number of carbon atoms. So this is the small whole number ratio, this one, of hydrogen atom, of course, that react with the same number of carbon atoms. Definitely, because for the first compound the number of carbon atom is 2, and for the second compound also the number of carbon atom is 2. Here is another example as well as the application of law of multiple proportions. Hydrazine, this is the formula, is a corrosive liquid used in rocket and jet fuels. Ammonia, this is the formula of ammonia, is a gas that can be used as a cleaning agent. How do hydrazine and ammonia illustrate the law of multiple proportions? Here, to justify this question, we have to take the help of the statement of law of multiple proportions. And the statement is just as before, when two elements combine with each other to form more than one compound, the mass of one element that combine with a fixed mass of the other forms a simple whole number ratio. Here both the compounds follow the law of multiple proportions in the fact that the small whole number ratio of nitrogen is 2:4. This is for the first compound, hydrazine. And if you simplify, you will get 1:2. Whereas for the second compound, this one, this ratio is for ammonia. So for this compound, the ratio of nitrogen and hydrogen is 1:3. For the first compound, the ratio of nitrogen and hydrogen, first compound, ratio of nitrogen and hydrogen is 1:2. And for the second compound, the ratio of nitrogen and hydrogen, this is for the second case, it is 1:3. Now let's look at the quantity of nitrogen. In both the cases, it is fixed as 1 over here and 1 over here. Now, if we compare the ratio of the masses of hydrogen in both the cases, this ratio is going to be 2:3, which is again a small whole number ratio. So definitely these two compounds where the elements are nitrogen and hydrogen respectively, they both illustrate the law of multiple proportions successfully. Thank you for watching the video. This is all about of today's discussion. Wait for the next video for law of reciprocal proportions.